Good morning, FHS. Today is Monday, October 23rd, 2023. Please join me in silence. Stand if you are able and join me in the pledge. One nation under God, indivisible, with liberty and justice for all.
All right. So I hope you guys had a nice, restful, long weekend. Last time I saw you guys, we were 2 days into section 4.7, which was inverse trig functions, and we need to wrap that up. So this will be our last full day, and then on Wednesday we will have our 4.7 quiz. And again, to me, this is one of the harder things we do, just because of the amount of information that we have. So of course, studying for your 4.7 quiz is going to be important. I do have some assignments I ask you to turn into Google Classroom, specifically worksheet 1 and worksheet 2. Those two should both be finished. I know initially we had skipped questions 3 and 4 on both of those, but I did ask that you go back and finish those last time. So that's 2 of the things I'm asking you to turn in. Another thing I'm going to ask you to turn in is the book work number 42, and you guys started on this last class. And this is going to be where we spend our class time today, giving you time to work through it and answering questions as you get to them. So you need to have that out to see where you left off last week. If you didn't get very far, that's fine, but you definitely need to finish and have it turned in by Wednesday. That practice is certainly imperative. And then the one handout I had for you guys this morning is number 43. It is worksheet number 3. You can see out to the side there, I have that it is optional though. So if after you've done worksheet 1 and 2 completely and the book assignment completely, if you realize you need more practice, do worksheet 3, and if you turn it into Google Classroom, I'll even give you a homework grade for it. And if you don't feel like you need more practice, then it will just be an X in the grade book. So it won't help or hurt you, but just try to give you that opportunity. So of course you should take on the extra practice if you know you need it without the points, but giving you the points if you fully complete it. Okay, so as we've done with book assignments in the past, I need to give you some time to work before you have some questions ready. But since you guys started on this last time, some people may have a question or two ready to go. I guess while this is fresh in my head here, it is good for you to know that the quiz is most like worksheet 1 and worksheet 2. Those are not exactly practice quizzes, but that's what it's most like. We will ask you all the stuff in the table, the domain of all 6 inverse trig functions. That should be just knowing one new thing for all 6 of those. Knowing the range for all 6 trig functions, which is super important. And then a handful of unit circle type questions in number 2, a handful of sketch a triangle questions like in number 2, maybe a question or two about graphing inverse sine, inverse cosine, inverse tangent. That's not on worksheet 1 or worksheet 2. And maybe a question or two about using a calculator that we talked about last time. Now on our quiz it will be no calculator, but as we've done in the past, we can just make the questions multiple choice, and you can pick the one that represents what you should do if you had a calculator. Okay, so again, if you have some questions ready, there's no reason to wait. We might as well clear those up now. So from last Wednesday when you started on this, is there anything that you tried that you know you would like some help on? Any questions we can just start class with? Okay, then I will bug you in 10 minutes for questions. So if you get to one, of course don't give up instantly, but also don't spend too long on it. Move on pretty quickly and then be ready to ask. It has been 10 minutes, so let me check back in with you and make sure that something hasn't come up that you would like some help on. So, anything from the textbook question that you'd like me to go over?
Could you go over 13?
Number 13. I will. Let me check this real quick. Okay, so number 13 wants to know inverse tangent at or of negative square root of 3. So basically, what angle has a tangent ratio that's negative square root of 3, or negative square root of 3 over 1, if you want to think of it as a fraction. So this is a ratio that shows up on the unit circle. So the long path is going to be, you're going to have to think about where tangent could even be negative. Tangent's positive in 1 and 3. So that means that tangent could be negative square root of 3 somewhere in these quadrants. You could pick the middle one, and you could do sine divided by cosine, but it doesn't give you the value you want. Directly across the unit circle, the tangent values are the same. You could guess and check this one, and when you do sine divided by cosine, you also don't get what you want. This is why this is potentially the longer way. And then finally, we only do 3 points in each quadrant, but eventually you need to try 2 pi over 3. And so directly across from that would be 5 pi over 3. Okay, the shorter way to do that is to just memorize the tangent values. Everything in the middle of each quadrant is either 1 or negative 1. Everything near the y-axis is either the square root of 3 or the negative square root of 3. And everything near the x-axis is either negative square root of 3 over 3 or positive square root of 3 over 3. So either way, you've got to be able to locate those 2 spots. And if that takes you a minute, then that's fine. Accuracy is more important than speed here. Okay, so now that we know where tangent is negative square root of 3, the next thing would be you need to know the range of inverse tangent, because that tells us which one of these is our answer. And so I always suggest that you draw that in your figure. It helps remind me that the range of inverse tangent is negative pi over 2, don't include it, to positive pi over 2, don't include it. And it gives me a visual that this location doesn't give me my answer, but this location does. And then the last thing you have to be careful about on these is it's not just finding this spot and naming the spot. Again, normally I would call this 5 pi over 3. Your final answer has 0% chance of being correct if it's not within the range of inverse tangent. That's the whole point of us even memorizing those. So instead of saying 5 pi over 3, you could say negative pi over 3. That's the answer it's looking for. So you have to know the unit circle. You have to know it well enough to find tangent values as well. You have to memorize the range of all 6 inverse trig functions. And then you have to make sure that your final answer actually lands within that. Okay, is anybody else going to ask about 13? Need anything more specific? Okay. And now, of course, when you guys ask these questions, I'm trying to go pretty in depth to try to help fill in whatever gap you have. In theory, though, if you know the unit circle and you are close or have the 6 inverse trig functions memorized, these questions really shouldn't take you too long. I know tangent's always a little bit more of a pain, but if you memorize tangent values, the first step should take just a second. Drawing in the range of inverse tangent should take you 1 more second. Seeing where your answer comes takes a 3rd second, and then making sure you name it in the correct way If you really know those things, these questions aren't like, I don't know, they're not a ton of steps at least. So they've at least got that going for them. Okay, somebody else have another question or two ready?
Can you do 39?
Question 39, sure. 39 is kind of weird in what it's asking you to do, but it's not a hard question. It gives us this picture, and it says use an inverse trig function to write theta as a function of x. So what that means is it wants an equation. Theta is equal to what in terms of x? So I should only have x's over here. So what you could do is you could say, well, from this angle, I know something about the opposite and something about the adjacent. So I could say tangent from this angle is opposite over adjacent. But to go from tangent theta equals to just theta equals, you have to do inverse tangent. So here is theta in terms of x, an equation for theta where x is the only variable in there.
That's it?
That's it, yeah. So really what you should be doing, or should have been doing a couple weeks ago when you found angles, but it's trying to emphasize this. If you have tangent theta equals, you can change it to theta equals by doing inverse tangent. So, okay. If you've got more, go ahead and keep them coming. Yeah, Kayla. Number 11. Okay. So again, a lot of these questions have a longer version and a shorter version. Obviously, you want to aim for the shorter version. So with question 11, well, first off, it's been I haven't seen y'all since Wednesday, and part of it was because of 3-day weekend. But remember, arc sine is the exact same thing as inverse sine. It's just, sometimes they ask it this way, sometimes we'll ask it that way. You can see even in your textbook, it's pretty interchangeable. And then I tried to help steer you in one of two ways when you do these questions. If this is a ratio that sounds like we memorize on the unit circle, then figure out where it happens on the unit circle. Sine, I'm used to being a half, a square root of 2 over 2, a square root of 3 over 2, 1 is 0, but I don't remember any time where it's a 3. So if it's not unit circle, then you should sketch a triangle. Inverse sine cares about quadrants 1 and 4 only. Sine is positive in quadrant 1, negative in quadrant 4. So if this was inverse sine of something negative, I would draw my triangle in quadrant 4, but since it's inverse sine of something positive, I would try to draw it in quadrant 1. Okay, you might want to think of 3 as a fraction, and sine is opposite over hypotenuse. Now, the problem is, you can sketch this picture, but a picture is never going to help you figure out how big the angle is. Except if you do this, I think maybe it will kind of help you see what's going on here. There's something wrong with this. There's no way your hypotenuse is 1 and your leg is only 3. Your hypotenuse has to be the biggest side. So you could go through all of that work to figure out that it's not possible. This was the long version of the question. The short version of the question is to realize that we don't ask you to memorize the domain and range of these just for fun. The domain is -1 to 1, and what this is telling us is that it doesn't make sense to plug in a number bigger than 1. So if you know what domain means and you have that memorized, you could have gone to not possible right away without having to dig deeper. There is no angle that has a sine value of 3. And of course, now that we've talked about graphing as well, that should kind of make sense. Sine goes up as high as 1 and down as low as -1. He's never up here at 3. So, unless you start changing the amplitude and stuff. But okay, maybe 2 more questions before I set another timer, give you a few more minutes.
You do 45.
45. Let's see, 45 has two parts. Sine of arc sine of 0.3. So anytime it has more than one piece to it, I just carry down the outside piece and worry about it later. This 0.3 kind of bothers me. I would change it to, see, that's the same as 3 over 10. I really want it to look like a fraction. Okay, so this is not a sine ratio I'm used to on the unit circle, so I would sketch a triangle. Quadrant 1 or quadrant 4, because it's arc sine. It's positive, so quadrant 1. Sine is opposite over hypotenuse. 99% of the time you need to use Pythagorean theorem to find this side, but on this question it just wants to know what's the sine of that angle. Well, sine is opposite over hypotenuse, so that or that, either one of those. Basically these two are undoing each other. I don't show that to you in this way because sometimes students oversimplify that. This doesn't always cancel out this. It depends on if it's a regular trig function on the outside or an inverse trig function on the outside. It depends on what the angle is, if there's an angle. So I try not to, I don't know, show you any shortcuts because students don't usually apply them correctly. But I made a triangle out of this, and then I wanted the sine of that, which was just the exact same information I just threw into it. So the answer stayed the same. Okay, one more, and then I'll give you some peace. Okay, then try to get a few more under your belt in the next 10 minutes, please. 10 more minutes and I'll ask for more questions. You need to put your name on the board though, or leave your phone. Huh? No, I mean I want it over here. If you're gonna leave your phone. That way if you forget to bring the pass back or something, then I've got collateral, or I at least know who has it. Bless you. Bless you. almost another 10 minutes, so let me disrupt you here for a moment, give you a chance to ask some more questions. So, other things coming up in the book assignment that I can help with.
Can you use 63?
63? Sure. Okay, so 63 has two parts. The cosine on the outside, just carry it down so you don't forget about it, worry about it later. And the inside part, again, not necessarily easy, but you guys should not be hesitating on what you need to start off with. Either this is something that sounds like it's from the unit circle and you work it like a unit circle question, or it doesn't and you need to sketch a triangle. 2x, or if you think of it as a fraction, 2x over 1, certainly is not some ratio I memorize on the unit circle, so I know I should sketch a triangle here. Since arcsine, his range exists in quadrants 1 and 4, that's why you should draw your triangle in quadrants 1 or 4. 1 if it's something, the arcsine of something positive, because sine's positive in 1. Draw your triangle in quadrant 4 if it's arcsine of something negative, because sine is negative in 4. This is a positive 2x, so that's how I would know to sketch this in quadrant 1. So sine is opposite over hypotenuse. So here is the angle that has a sine of 2x. His opposite to his hypotenuse is 2x. So, as most of these questions go, usually you have to label two sides with SOHCAHTOA. Usually you need Pythagorean theorem to find the third side. Make sure you don't try to go further on this. I think we talked about this last week, or at least we did in a few of my classes. So if you're not sure why this doesn't break down to 1 minus 2x, then speak up so I can go over it. But otherwise, there's the third side, and I want to know what's the cosine of this. So adjacent over hypotenuse. That should be the answer you end up with. And of course, it's kind of weird feeling to have x's in your answer, but if this was in terms of x, then this should be in terms of x, and the cosine, two of those sides have x's in them, then your answer is probably going to have an x in it as well. Okay, Lucas, was there something more there? That's enough? Okay, any other textbook questions ready to go? Okay, this time I will do a 15-minute timer. We still got about 40 minutes of class left, or actually 50 minutes, about 50 minutes, so still a lot of time. question?
Well, it's saying domain though. I think you're looking at range. That's in terms of rating. This would be, same as the range of cosecant, so negative infinity to negative 1 and 1 to infinity. So, I would say or I'm sorry, it'd be a ratio. And an inverse function, when you plug in the ratio and the output.
Okay, you want to flip it? Okay. Any, have any questions? What's easier than this? What's easier than this?
Yeah, but I should take that out.
Okay, so I can see some people are finishing up. So remember, just a reminder that there's a handful of things to turn into Google Classroom. If you did not go back and completely finish worksheet 1 and 2, that includes questions 3 and 4 on both of those. Just because I didn't have you do them the first day because we didn't have time, I did ask you to go back and finish them last time. So if you forgot to do that, I don't want you to miss easy homework points. And at worksheet 3, feel free to practice some of it, any of it, none of it. But if you're already finished with the bookwork, you may know which question types you're the weakest at. And feel free to just do parts of it if you want to just do parts of it. I do have the solutions to it on my website like the others, so you can make sure you're doing it right. And then of course, if you end up doing all of worksheet 3, as I said at the start of class, I will give you a homework grade for it. But if you don't feel like you need the extra practice, that's fine. You don't have to do it. It won't count against you. We've got about 4 more minutes, and then I will give you guys another chance to ask some questions for me to work out on the board. sorry about that. Okay, so it's been 15 minutes. I know you guys are getting closer to the end of the book assignment if you're not finished with it, but is there anything else you have found that would help you prepare for our quiz next class? Any of the book questions I can help with?
Did you go over 45?
Sure. 45. We already did 45 today, though.
Oh.
It's right here. I'll leave that up for just a second. Made a triangle, and then I could just turn around and do the same ratio. So 45 is kind of a weird one. If you like try to phrase this in a sentence, it's basically asking you, what's the sine ratio of an angle that has a sine ratio of 3/10, which is why it comes out to 3/10. 3/10 is the sine of an angle that has a sine of 3/10. So, okay, others? Okay, well, we still got about 30 minutes of class, so I will do one more 15-minute timer. I'll give you one more chance to speak up then. Of course, if you guys have something more specific, you want me to look at your work, try to guide you, then just call me over or bring it up here to me if you don't need me to work the entire thing. Okay, one last chance for anything you'd like to see worked out on the screen. Anything from the textbook. Okay, well, you guys have about 15 minutes, so if you do find something in 15 minutes, then please go ahead and ask. You can bring it up here to me or call me to your desk. I guess 2 quick reminders I'll give you, even though I know I've told you this. Your quiz will ask you for all of this stuff in question 1 on all of the worksheets that we did, the domain and range, and I think those are half a point each, so 6 points from your quiz just comes from just straight up memorizing those. It is matching though, so you don't have to try to memorize how to write the answer. You need to know how to, preferably this, and then know how to change it to interval notation. So make sure you know that, because that's too many points to give up where you could not even understand trig and still get those points right. And second, remember in unit 3 we only do 2 sections, 4-7 and 4-8. 4-7 is the tough one, so as always you should put in your best effort, do the best that you can on the quiz. That should mean that you need to study less when the test rolls around, but in 4.8 more than half of the work is finding side lengths and angles using SOHCAHTOA, which you've already done. So there's an old geometry thing we have to review that gets mixed in to some questions. We have to talk about what bearings are and practice those. It's a different way to work with angles, but for the most part 4.8 is pretty easy for people. So putting in a good effort on 4.7 before the quiz should make the next week and a half in this class go pretty smoothly. So because 4.8 you won't have to put too much outside time on, and then we'll review and test. So 4.7 is definitely the challenging part of this unit. Okay, but that's the last thing that I've got. So again, if you guys do find any other questions, if you'd like some help on, just let me know.